Okay, class, here we are, lesson 4.3, working with rational exponents. Another fancy name for rational exponents, that's what we use for fractions. So it's the same thing as working with fractional exponents. All right, before we get to that, let's do a recap or a warm-up of last day's review on exponent laws. Okay, 1a, looking at our base. Our base is -8, and our division law tells us that we need to subtract these. So it's going to be 4 subtract 5, which equals -8 to the -1. Remember, folks, to express as a single positive power, we always take our negative exponent and flip the fraction and make it positive. The exponent. And remember, folks, that you can never have a negative as a denominator, so either bring it out front or up top. All right, taking a look at the second expression, ladies and gentlemen, our base is 1/10, and multiplication law tells us we need to add them. Okay, so it's 1/10 to the exponent of 2. All right. Make sure, folks, when you're adding a negative that you put the brackets around the -4. It's bad form to have two signs side by side like that. All right, example C. Again, we have a base here of 7. We got to work inside the bracket, the big brackets first. So we're going to use our division law of 2 subtract 4, which equals 7 to the -2. I apologize, that's all raised to the -1. Okay, and then we're going to use power of a power law. You may be inclined here, ladies and gentlemen, to do inside the brackets and flip the fraction, but what you should realize is when you have a negative inside the bracket, that's going to flip it, but then you've got a negative outside the extra power, which will flip it back. So basically, it's worthwhile to remember to use your power of a power law first. Okay, leave that negative exponent law till the end, because what you will realize is that you get 7 to the power of +2. Because a negative times a negative becomes a positive. All right, example 2. Express answers in rational form. Rational form means in fraction form. All right. Taking a look at our first expression, it's a fractional base, which tells us that the exponent applies both to the numerator and to the denominator. So that equals 16 over 49. Taking a look at our second expression, ladies and gentlemen, we notice first of all that we've got a fractional base, but we're raised to a negative exponent. So we're going to flip the fraction to make the exponent positive. And then we're going to evaluate our expression by remembering that the exponent applies both to the numerator and to the denominator. Okay. Taking a look here, folks, we're going to have 3 times 3 times 3 is 27, divided by -2 times -2 times -2 is -8. However, it's improper to leave the negative as a denominator, so bring it out front or up top. All right. Okay, example C. Taking a look here, folks, our base is -3. Okay, and our division law tells us that we need to subtract these. So when you subtract a negative, you're actually becomes adding it. So you end up here with -3 to the exponent of 3. And -3 cubed is -27. All right. So ladies and gentlemen, our lesson today is going to refer back to when we did our lesson on radicals. Okay, just remember, folks, that we learned when you have a square root 25, that equals 5 to the 1/2. Or we learned that when we have the third root of 27, that equals 27 to the 1/3. We're now going to go from the exponent form back to the radical form to help us. Okay. So looking here, folks, at example 1a, it says to simplify, then evaluate. Simplify basically means express as easy as you can, and then to simplify it. All right. So first of all, taking a look here, folks, we know that using this formula, the n, or the denominator of the fraction, is the root. So that tells me this is the third root of 27. And the third root of 27 is 3. Next example, taking a look at our fractional exponent, it's to the power of 4, or it's to the denominator of 4. So what does that mean? It's 16. It has the fourth root to it. Okay, so the fourth root of 16, plug in your calculator, is 2. If you're not sure what button to look for, usually it's an x with a root, or it could be an x square root with a y. Take time, ladies and gentlemen, right now to figure out how to plug that in. All right. And last example, I think this is the easiest one. Square root of 25 equals 5. Now notice, ladies and gentlemen, in A, B, and C, in all these cases, that the numerator of our fraction exponent is always 1. Let's take a look at this next example where it says to consider 16 to the 3 over 2. Okay? Well, what do I know? I already know, ladies and gentlemen, that the 2 at the denominator means the square root of 16. So I know that already, because that's the second root. But then to apply the 3, it's just going to be raised to the power of 3. So basically what I'm doing, guys, is I'm splitting up the power of the power law. So I'm basically taking it 16 to the 1/2 times 3. Notice 1/2 times 3 is 3 over 2. So I'm just using the power of the power expression. And then we can simplify this because the square root of 16 is 4, still raised to the power of 3, which equals 64. So what's important to remember, folks, is when you have a fractional exponent or a rational exponent, the numerator is actually your exponent, where your denominator is your root. All right, and it says right here, n is the root and m is the exponent. So let's write that down, ladies and gentlemen. And why do we need a to be greater than 0? Because in some cases you can't take the square root of a negative value. And that's when you have an even root. Okay? All right. Let's take a look at some examples here. So we have 27 to the 2/3. So again, I start with my root. I've got the third root of 27, and I'm raising it to the exponent of 2. So third root of 27 is 3 squared, which equals 9. Take a look at our next example. We've got 25 to the 4 over 3 as our power. And what we need to do is realize, hey, what root do we have here? We have the third root of 125, and we're raising that all to the 4th power. Using your calculator, if you're not sure, the third root of 125 is 5. Still have it raised to the power 4. Plug that in your calculator, and you should have 625. All right, next one. The 5th root, we have a root of 5. So that becomes the 5th root of 243, but that's all raised to the power of 3. Okay, so the 5th root of 243 is 3. Again, use your calculator to help you figure that out. 3 cubed is 27. Okay, last one, and be careful with this one. It's hard to see, but there's a negative exponent. Okay, so you have to treat that a little differently. All right, so here we go. I apologize. Let me move that back up. So taking a look here, first we have to realize that, hey, we have a negative exponent, so it's not proper to simplify it and leave it like that. So simplify means to get it as a single power. So it's 1 over 25, all raised to the negative 3 over 2. Okay? Well, you should realize, ladies and gentlemen, I apologize, it's not negative 3 over 2, it's positive 3 over 2. Because we've flipped it, so it's just 3 over 2. What we should realize, folks, is 1 to any power is just going to equal 1. but we can apply this exponent to the denominator. So what we're looking for is the square root of 25, all raised to the power of 3. So it's going to be 1 over square root of 25 is 5, and cube it. So it's going to be 1 over 5 cubed, which is 125. Good. All right. Notice in each of these examples, guys, it was easy to get either a rational form or a solid answer. What happens when the roots don't go in evenly? Okay. Let's take a look with this next example. So it says sometimes a calculator must be used. Okay, and I don't mind if you use calculator for the other one as well. But the first thing I'm going to cue in here with this example here is it asks you for the 4th root of 27 and then raise it to the power of 5. Can we get the 4th root evenly of 27? Okay, so no, because there's going to be a decimal here. So that's where you're going to have to use your calculator, because you're going to have a decimal. Okay? So basically, you could plug this in. You could use your calculator and say, hey, what's the 4th root of 27? And then raise that to the power of 5 to get your answer. Or you could put it all in power form. So you could say 27, and then your y to the x, or hat button, or x to the y, whatever button you have. And then put opening bracket. So you have opening bracket, and then go 5 divided by 4. Closing bracket equals, okay, or you could do it in 2 steps. It's up to you. And let's just round it to 2 decimal places. So it's going to be 61.55 approximately. Okay, let's try these next ones in our calculator. So again, use the same step pattern. You can either do it all at once like this, or you can break it down into 2 parts. Do the root first and then express it to the exponent. It's up to you. Okay. Doing the first example, you should get 66.41 if you plugged it in your calculator correctly. And just to note, folks, that this exponent here is 0.8. And you say, hey, Muzar, that doesn't fit in today's expression of rational exponent. Just remember, folks, we could change that to what's a fraction, meaning 0.8. That's really 4/5, right? So that's why it does fit this case. Okay. However, when you have a base of 12, there is no either squared or cubic root that's going to go in evenly. I don't recognize that as one of my special numbers. So what we're going to do is just use your calculator and plug it in as it's shown. Okay. So you should plug it in and get an answer of approximately 7.30. All right, moving on, getting a little harder now, folks. Example 4, simplify using power laws, then evaluate. Now, the thing here, folks, is it asks you to use your power laws. There are easier ways to solve this if it didn't say that. However, it's asking you to use your power laws. So in order to do your power laws or your exponent laws, we have to express our values as or in exponential form. So how do we express root 6 as an exponent? Well, if you remember back from the first formula we looked at, it's 6 to the 1/2, right? Times 6 to the 1/2. Then what we need to realize is, hey, this is a multiplication law, so you add your exponent, so it's 6 to the 1/2 plus 1/2, which equals 6 to the power of 1. That's single power, and then it's just 6 when you evaluate. Okay, second example, getting a little harder now. Okay, so again, we've got the square root of 625. That means 625 to the 1/2. Okay, times 25 to the 1/2. All divided by 125 to the 1/3. Now here's a hard part, folks. Unlike example A, the bases were the same. In B, the bases are not the same. So how do we get the bases to be the same so we can apply exponent laws? Is to think of our cubic and our square roots. For example, square root of 25 is 5. Square root of 625 is 25 itself, so you could take another square from that, so we've got 5. And the third root of 125 is 5. You need to find a number that's going to be the same base in each case. So we're going to express everything as an exponent of 5. So for example, 625 equals 5 to what power? So it equals 5 to the power of 4. Then that is still raised to the 1/2, guys. Okay? Times, how do we write 25 as a power of 5? It's going to be 5 squared, all raised to the 1/2 still. And then on your denominator, we're going to have what 125 is really 5 to the power of 3. And that's all still raised to 1/3. Now we can use our multiplication or power of a power law. Okay, so what do we end up with here? We end up with 5 times 1/2, which is 5 to the power of 2. Okay, sorry, said that wrong. 5 raised to 4 raised to 1/2, and then you simplify your exponents there. So it's 5 to the power of 2 times 5 to the 2 times 1/2, which is just 5 to the 1, or just 5, divided by 5 to the power of 3, all raised to the power of 1/3. So 3 times 1/3, they cancel out, so it's just to the power of 5. And then you can use your exponent laws, because that's what it tells you to do. So use your exponent law. So it's going to be 5 to the 2 plus 1, because you're multiplying. And then you're going to subtract 1 because you are dividing. So again, these two cancel out. So you're left with 5 to the power of 2, which equals 25. Now, ladies and gentlemen, if it just said on your test to evaluate and didn't include that you had to use the power laws, here's a different way you could solve it, and this is using radical laws. So we're going to take a look at the same expression, and I'm going to show you how easy this can be. All right. So remember when we took a look at an entire radical, how do we make it a mixed radical? Okay, so what square root value goes in evenly to 625? So basically, you look on your matrix and you notice that it's 25 times 25. That becomes the 625. And then the square root of square root of 25 is just 5. All right. Then we need to find out, hey, what is the third root of 125? That is 5. So what I notice I can cancel out right away, guys, are our 5s. I'm also going to look to say, hey, square root of 25, that equals 5. But I still have root 25 left over. But what we should recognize is that the square root of 25 itself is 5. So we're looking at 5 times 5, which equals 25. I find that's an easier method to solve this if it doesn't specify how you need to solve. All right. Okay, last example in this question 4. We have the third root of 64 times the fifth root of 32. The frustrating part here is the bases are not the same, so we have to do like what we did in B to get the bases to be the same. Okay, but first of all, let's express it as exponents, or as exponential form. So it's going to be 64 to the 1/3 times 32 to the 1/5. Okay. We want to find out what base that it goes in evenly into 64 and to 32, and you're going to find that it's base 2. So it's going to be 2 to the power of 6. That just equals the 64. And then that still times to the 1/3. And 32 is 2 to what power? It's 2 to the power of 5. And that's all raised to the 1/5. Simplifying, do your power law. So 6 times 1/3 is just going to be 2 to the power of 2. And the good thing about your second one is 5 times 1/5. It just simplifies that to 2 to the power of 1. Using your exponent laws, that's 2 to the 2 plus 1, which equals 3. And 2 to the power of 3 is 8. Okay. Moving on, last two questions. They're a little bit more difficult, but we can handle them together. No worries. Okay. 16 to the 0.25 over 16 to the 5 over 2. The good news in this case, folks, is our bases are both the same, but we got to figure out how to deal with a decimal versus a fraction. Well, hopefully you recognize that, hey, we can take our numerator and make it into a fractional exponent. So 0.25 is 16 to the 1 over 4 divided by 16 to the 5 over 2. Because the bases are the same and we have a division sign, we need to do what? We need to subtract, keep the base the same, and subtract the exponents. So when I take 1/4 and I'm going to subtract 5 over 2, I'm just going to change that to a fraction of a denominator of 4. So it should be minus 10/4. Now that I've got, in our fractions, I've got lowest common denominator, now I can subtract. So it's going to be 16 to the negative 9 over 4. First thing that we notice is that that's not a proper single power. We need to make it positive because it's negative. So it's going to be 1 over 16 to the 9/4 to make it positive. Okay. And then we're going to take a look at realizing, hey, 1 to any power is going to be 1. But we can take a look at the 16. So it's the 16th, it's the 4th root of 16. So the 4th root of 16, all raised to the exponent of 9. Plug in your calculator. 4th root of 16 is 2. So you've got 2 to the power of 9. Plug that in your calculator. And you're going to have 1 over 512. Good. Let's try this last one, guys, and we can get her done. Good news about this last one, folks, is the base is still the same. So we can use our exponent laws. Again, to multiply, you've got -4 plus 6, all divided by 25 to the 5 over 2. Okay, simplifying the numerator, you're going to have 25 to the power of 2 divided by 25 to the 5 over 2. Notice we're going to do a division law here, but we need to have notice that the denominator is a fraction is out of 2, so we need to create the numerator in the top fraction as a denominator 2. So I'm going to change that to 4 over 2, subtract 5 over 2. Okay, because 4 over 2 is really 2. So it's going to be 25, ladies and gentlemen, to the -1 over 2. Notice that's negative, so it's going to be 1 over 25 to the 1/2. And then simplifying that, we apply the square root. So 1 over the square root of 25 equals 1/5. There we go. Just again, ladies and gentlemen, if the bases are not the same, try to get the bases the same so then you can apply all your exponent laws. Again, come see me if you need some help. Here's today's homework, page 229, numbers 1 to 4, ACE. Do all the odd ones, etc. Keep going. But if you need some extra practice, please go ahead and do B and D if you need to. Then 6, and try 14 because it's a tricky one. All right. Here ends today's lesson, folks, on 4.3. Please come see me if you need any help, and have a great day.